let me know when I have to switch the slides and
Okay.
whatnot. Say click or Seb or whatever, something. Give me just, yeah.
Okay, so my task today is to present these two chapters. As I said, I might be completely wrong in my interpretation, but the main point I see is that he tries to kind of show in what way one can interpret novel scientific discoveries so as not to presuppose that there exists something more than the concrete events happening. In Einstein's case, that would be space-time and its contortions that he counters with space-time systems, if I'm correct. And in quantum mechanics, it's this Bohrian way of speaking about lumps of matter, so the nucleus and the electron, which kind of oscillate, whereas Whitehead is gonna try to explain how the oscillations themselves can represent, or rather really be the matter instead of matter, the concrete. Okay, so at the beginning of the chapter on relativity, he pinpoints a crucial difference between classical mechanics and relativity, which is very apparent out of when one compares Galileo's and Michelson-Morley experiments. As Galileo's experiment, his bowling down the Tower of Pisa, was very simple, not technically demanding, and thus it was independent of the advancement of technology. And of course, he proved the uniformity of acceleration on Earth. While Michelson-Morley experiment was actually a very complex and technically demanding, and of course was heavily dependent on all the advancement that had happened before. And it of course proved, as we all know, that the speed of light is constant irrespective of the frame of reference, or another formulation would be that ether is not the medium, does not exist, or there is no medium through which light propagates, at least if this medium were at absolute rest with respect to light. So in a sense, classical mechanics articulates common sense because it deals with everyday situations, just construed a little bit differently, while relativity demands a bit more complex notions of time and space, as it tries to investigate phenomena which are not readily available. So this is the Michelson-Morley experiment. I don't know how many of you know it, but basically the point is that you have this ether, which is gonna kind of basically a bit of a Doppler effect, and you can expect that when light starting from the source comes back to the sensor, you're gonna measure some kind of interference pattern. If ether introduced a disturbance in the flow of the light waves, of course, they realized this did not happen. There was no interference pattern, which proved that there was no kind of absolute medium at absolute rest for the propagation of light. And of course, Einstein's theory is just way to remedy the situation, to kind of show how speed of light can be constant. And of course, this Einstein's theory of relativity is a heavy blow to the classical scientific materialism, which of course presupposes a definite present instant at which all matter is simultaneously real. It's quite easy to imagine this, as I already said. It's just an very articulate explication of common sense. But of course, in the modern theory, there is no such unique present instant. This is also known as relativity of simultaneity, where the sequence of events, the order of events is actually dependent on the velocity with which these events of the observer actually. Can you go on? And Whitehead is going to, of course, counter the naive interpretation, which takes space-time as some pre-existing kind of frame within which events can take place. later he's gonna say that the spatio-temporal relations are not external, rather they're internal. They unfold within the event itself. But of course, for that, he has to define what an event is. He defines it as a grasping into unity of a pattern of aspects, very mathematical way of kind of doing philosophy. But of course, events, if I understand correctly, can actually be anything. So if we want to have a meaningful event, we have to introduce the notion of endurance, which means that a pattern which is exhibited in the prehension of one event is also exhibited in the prehension of those of its parts which are discriminated by a certain rule. What this means is that kind of we can recognize different time frames within which the event remains in a sense coherent and recognizable. Could go on. So endurance actually differentiates space from time, as the enduring object is enduring through time, not through space as much. So it's basically, if I understand correctly, a relation between spatial nows. And of course, these spatial nows can also be considered as temporal sub-events, in this sense that it is the analysis of endurance through time that provides us with this exact rule for discriminating partial events or patterns that are constitutive of the whole enduring object, of the whole event. So his example of a thumb is pretty telling, as he pinpoints it, not explicitly. I think I understood that this is a spatial part, but of course, if you want to consider the temporal endurance of an object, you have to take into account the body as a whole during a specific time frame. And then, of course, the pattern is enduring. Of course, now we come to the interpretation of relativity, which is super fascinating to me. And his main question, of course, is how many meanings of time and space are there? Because it seems that normally we would think of one meaning, right? So yeah, the speeds just add up. And even if you drive by car, the speed of light, if you drive in a vacuum, is not gonna be faster than if you're standing still. This entails that time and space have multiple meanings, but of course, how can we now understand these multiple meanings with respect to something more intuitive, not trying to explain it by involving complex mathematical notions like space-time. And actually, Whitehead's point here would be that every enduring object is to be conceived as at rest in its own proper space and in motion through any space defined in a way which is not that inherent in its particular endurance. So there is something in this pattern that constitutes the endurance of the object, which also determines whether the endurance, the kind of recurring pattern belongs to a proper space or time-space system or not. The way I understand this is that if you take for example, the famous twin paradox, right? When you have two identical twins, you put one on a spaceship, he flies nearly to at the speed of light, but then he comes back and he's younger, much younger than his older brother, or like older but not older brother. If one interprets this in an Einsteinian materialist way, one actually reduces the twins to simple points in space, and does not, and we then don't really understand that these twins are constituted by recurring patterns, and these patterns determine actually the speed of time that it's gonna at which the speed of time, the speed of development or the speed of oscillation of a particular enduring object, and this can be different. Because you could actually say that even with Einstein, the stubborn sameness of the material is kind of a remnant of the naive scientific picture, which took absolute space and absolute time and absolute material as something that exists. Because if we take the two things are identical and then all of a sudden they're not, this doesn't quite make sense. And that's why I think twin paradox from Whiteheadian perspective would really be a paradox, because you don't account, you just take the whole time frame, you don't account for the constitutive patterns which determine its existence. Can you go on? So there, he does two analyses, which the first one I really don't understand, the contemporary events analysis. I mean, is he trying to show that relativity is kind of that includes that if you connect like the events that precede and that succeed a certain event with another set of events, these events should be able to flow backwards? I don't know, maybe we can discuss it. That's the best interpretation I could come up with, so that relativity then is kind of inconsistent. Because I actually realized after I realized that yeah, relativity really just reduces everything to points. And then how can you speak about points that are in a different succession if these points really don't happen at all, or they do? It's not quite sure. And the second one, which we could also discuss, is the restatement of the law of gravitation. He says that he has some great formulas that he's going to reveal to the world. But yeah, perhaps someone knows more about this. Can you go on? Out of this first incomprehensible passage about the sets of events, I think flows this discussion about the relationship of events, relationships that one can find in an event. And basically, these relationships are internal and external. Internal are the relationships that it forms with itself and within itself, between aspects. External are those that it forms with other events and actually also eternal objects. As already stated, spatio-temporal relations are not external. They as we're going to see quite soon, they demand a certain duration, you will say. So internal relationships, I didn't quite get this division, but I suppose it's like the substantial activity of individualization enables the individualized complex of events, which in turn supports the substantial activity of individualization. But basically, in a way, the event, if it is endurant, it's stable, at least to a certain extent. So the event is what it is by reason of the unification in itself of a multiplicity of relationships. Can we go on? But of course, when you look at an event, you quite soon realize that after subtracting all the abstract relationships recognized, there are some left over, namely the external relationships, which probably constitute the patience of other events for the enduring object. I would understand that way. Sorry for all the yeah, next slide, but sorry for all the rudimentary mistakes. I was really in a hurry. So basically here we have an interesting dialectic between whole and a part, because the scheme of relationships, as thus impartially expressed, becomes the scheme of complex of events variously related as wholes to parts and as joint parts within some whole. Because when I analyze an event's relationships, I'm always going to have this split between internal relationships, which are the domain of its parts, and external, which are the domain of the more whole, encompassing whole that it is a part of. So the whole is evidently constituted of the part also. Yeah, as stated multiple times, there's this thing called process of realization, which is actually how, of course, time gets differentiated from space, because within this process, the pattern reiterates itself. And actually, the actuality of the space-time system is constituted by the realization of this pattern. And of course, when we consider two different time frames, or the speed at which time passes in relativity theory, we're not actually thinking about, we should not be thinking only about the time that had passed when we measured a certain property, but actually all the processes that enabled the quicker or slower passage of time. That is this process of realization. And of course, this realization comes through the reiteration of pattern, which requires, of course, a certain duration to manifest itself. And this duration is for him what he calls an epoch and a rest. Because if you take time as constituted by these reiterations of a pattern, time becomes a succession of these epochal durations. Of course, after this gets constituted, you can still go back and do limit processing on it, as Whitehead often does. But that does not mean that that kind of time and space wouldn't exist were it not for the patterned reiteration. Can you go? So he summarizes this quite nicely, that the epochal duration is not realized via its successive divisible parts, but it is given with its parts. So it's not like you have, once again, a framework of time and space within which you can use the points to write a line, as Kant does in his first paragraph, but rather as in the second, that the whole is always constituted epocally, atomically, but afterwards, so the space, the time come with the realization of a particular event, yet afterwards one can still even find a smaller epoch by which it can divide or even perform a limiting process. Yeah. The second chapter deals with quantum mechanics. I wasn't quite sure what he was talking about in the beginning, but I suppose it was the absorption emission of light by atoms, which is that when you shine a light on an atom, it's going to absorb certain frequencies, and these frequencies are going to be multiples of the Planck constant. And when you shine a light on it, you actually get this above spectrum, because the atom or the material kind of absorbed the light in those black bands. And it's quite a nice metaphor, though a bit problematic, I could say. That's actually in quantum mechanics, you have these quantum currencies, which one could understand as Planck's constant, but Whitehead would probably go in a bit of a different direction. But basically, you have a discontinuity. You cannot just take any wavelength you want. There are always multiples of the Planck constant or some Whiteheadian constant that we're going to discover someday, or systemic properties. Can you go on? I think he kind of talks about the Bohr model of atom. And in his criticism, he's actually quite prophetical. I mean, this turned out to be true, what he's talking about, the stationary waves. No? But basically, what he did with relativity, that the space-time does not exist by itself, is dependent on the events. The same he's going to do about the relationship between lumps of material and their vibration. He's going to show that vibration can be considered as this electron or this nucleus, probably also. So not as Bohr said, like we have really, 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 really small planets and they circle around the nucleus and then we measure this. Can you go on? So basically the problem is that the quantum theory wants trolley cars with limited numbers of routes, and the scientific picture provides horses galloping over prairies, right? So even though Bohr is inspired by this materialist doctrine, he kind of, he literally goes for epicycles of quantum world, right? So the orbits of the electron. Can you go on? So the way I gather it was, he developed two criticisms or interpretations of modern science, modern physics. First was vibratory locomotion, which deal with the problem of relativity. The second one is vibratory organic deformation. namely the emission of light. And it's crucial for us that we understand that this is a deformation. It's not an investigation of something that exists by itself. It exists in a certain system where it has equilibrium. And of course, the bit of material Bodo was talking about is complete organism for Whitehead. Can we go? And the indivisible parts that form the atoms are, of course, what he calls primates. But at the same time, he warns us that it's not really, if I understood correctly, it's not. This is not so much a concrete understanding in his, but more of abstraction, right? I'm not sure really how to interpret this, but yeah, we should probably note that. Of course, he says that when the particles are subjected to violent deformation, probably like acceleration, I don't know when this became popular, one can observe the dissolution of primates. And of course, what does this mean? Normally, primates are stable because they enter into a mutual association between other kinds of primates, and there emerges a certain stability. In the case of the atom, there is an electromagnetic stability, which enables the nucleus and the electron, differently charged, to shield themselves from the electromagnetic disturbances that could arise from the external environment, events, whatever. But of course, he asks himself, or rather the listeners, readers, if he fell down the rabbit hole of the undifferentiated sameness. But of course, he doesn't say he did. I mean, he insists that he didn't. I mean, there's such a thing as reiteration, which is an incomplete endurance, if I understood correctly. Somebody has to help me with that afterwards. But actually, this is the prophetic passage that I would like to read. It is that it is quite easy as a particular hypothesis to imagine as stationary vibrations of the electromagnetic field of definite frequency and directed radially to and from a center, which in accordance with the accepted electromagnetic laws would consist of a vibratory spherical nucleus, one set of conditions. And sorry, it's not a good quote. I wrote it wrong. And a vibratory external field satisfying another set of conditions. Basically, the way I gather this is the quantum field theory, kind of halfway. But yeah, can you go on? He, of course, insists that energy is proportional to mass, and even more that the supposition of a materialist theory that there is this presence of material can be completely eclipsed by the theory of vibration, which replaces this material by actually energy of the vibration in question. Then, if I understood correctly, in the end, he tries to kind of grapple with the particle wave duality. He's going to say that because we can, when we measure a one electron, we're going to measure a definite discontinuous repetition of a pattern. So a specific particular epochal manifestation, as he says. But if we want to interpret this in a more consistent way, we have to resort to electromagnetic fields, which are the ways within which the particular epochal manifestations kind of get their patternness, whatever. So, but I still don't know how, for example, this applies to the two-slit experiment. But can we go on? Yeah, so discussion, maybe somebody could explain to me this, his discussion of the relativity of simultaneity. It seems, I didn't quite explain this. It seems that Whitehead is gonna maintain that the emission of light or absorption of light is dependent on the systemic characteristics of a particular assemblage of the primates, so that there's no universal atomicity, as is supposedly Planck's constant, but rather organic systemic discontinuity, because when an atom emits a certain wavelength, he's going to change in a specific patterned way, and he's going to emit this discontinuous pattern. That's the way that's also why I think he talks about English and American currency. He doesn't talk about just one currency. So it seems that there is some organic aspect here. And the third topic could be the reception of Whitehead's relativity theory. Probably some of us know it a bit, some of you know it a bit better. I would be really interested if any physicists reacted to it, or if it just kind of got lost. But thank you.
Thanks, Izak. It was actually pretty good, given the overall content of the two chapters. Anyway, I think Matt wants to say something.
Izak, that was a great summary. I don't know if I could do any better other than just providing, like I did last time, some context. Whitehead did develop, so let me see where to start. I guess in 1922, he published his book, Principle of Relativity, where he's laying out, in addition to alternative tensor equations that provide a Euclidean account of general relativity. In other words, as he hints at in this book, Science of the Modern World, he was worried about some paradoxes that arise in Einstein's understanding of gravitation. One of those is this measurement problem that if space-time is warped by mass, then in order to measure astronomical distances, we would first need to know where all the mass is. But in order to know where all the mass is, we'd first need to measure it. And so the problem is that if space-time, if our rulers are contingently warped by masses that we don't know the position of in advance, Whitehead thought the way that Einstein was rendering his theory of general relativity was epistemologically incoherent. And so it's not that Whitehead was disputing the empirical confirmations of Einstein's theory that needed to be accounted for, but Whitehead thought that there was a conflation in Einstein's rendering between geometry and physics. For geometry, for measurement to be possible geometrically, we need straight rulers, and we need rules. I think it's rules of conjugacy, where you can, if you don't have a ruler long enough to reach to Alpha Centauri or whatever, you are able to use other means to establish straightness. But if you don't know how the ruler is curving in advance, you can't measure accurately. So this is why Whitehead thought he needed to articulate a theory of gravity that took these relativistic effects into account, but that was rooted in a Euclidean form of geometry. This is why Whitehead says his theory is more complicated, but nonetheless, it doesn't have this measurement problem. This was taken up by physicists for many years, for decades. Whitehead's rendering was empirically equivalent to Einstein's. It made all the same predictions. At some point in the 70s and 80s, some physicists argued that there was a tidal effect that should show up in Whitehead's rendering. It shows up, it's accurately predicted in Einstein's, has something to do with the gravitational influence of the galaxy. Einstein accurately predicts it, Whitehead doesn't. Now, Whitehead would say, I think, well, you know, we can adjust my particular rendering of this alternative approach to relativity to account for that, just as we adjust Einstein's equations to account for dark matter and dark energy and so on. So it's not necessarily ruling out Whitehead's approach, and that measurement problem still remains with Einstein's, but Einstein's approach has just gained so much momentum at this point that, you know, the alternatives aren't relevant. However, as Whitehead says, there are a lot of epicycles being a sort of appended to the scientific model of the universe at the largest scale. And so who knows, maybe the physics community will start to revisit Whitehead's approach more in the future. And there's one other thing I want to say that becomes much more clearly laid out in Process and Reality, where Whitehead distinguishes between what he calls a genetic account and a morphological account. Now, a morphological account would have to do with physical measurements in the space-time continuum, everything that's in the extended world, whereas a genetic account has to do with this process of realization that he's beginning to describe in Science in the Modern World, where he's describing the prehensive unification of many aspects of the environment by some substantial activity of individualization. This activity of individualization is a process of genesis, and he thinks there's a certain, when he says that there's an aspect of time which goes beyond the spatio-temporal continuum of nature, when he refers to the epoch or the duration wherein this gathering together or this synthesis of aspects from the environment takes place, this is the genetic dimension of reality. And for Whitehead, that's where everything concrete occurs. Spatio-temporal measurements for Whitehead become abstract. What goes on within the unification of an event, or what he calls an actual occasion of experience later, that's what's concrete. So the actual universe for Whitehead in its concrete form is what's realized in this epical process, this occasion of experience. And what physicists measure in terms of space-time would be a derivative abstraction from the relationship among actual occasions of experience. And so in Process and Reality, he clearly demarcates, okay, this is genetic analysis, this is morphological analysis. Sometimes he calls it coordinate analysis. And so you start to get a clearer picture of his approach to, basically situating metaphysics in relationship to physics. We need metaphysics to talk about these epical durations because they're not measurable. You can't subject them to the kind of quantitative empirical analysis that you would the space-time manifold. And he's just working that out in these chapters here. So if you've read Process and Reality, I think you'll see how this distinction is further developed, and I think stated more clearly in Process and Reality. Does that help at all?
It does, at least to a certain degree. Any further questions?
I would be really interested in this this continuity. I'm not sure if my reading is correct, but I really think he would not agree with the universal kind of way to measure the quantum phenomena, like a Planck constant. That is all dependent on the particular assemblage of primates that vibrate in a certain relationship.
Yeah, I mean, I'm not a physicist here, obviously, but my understanding of, the Planck's constant is that it has to do with this, I think it's called renormalization, where they get rid of some infinities in the math by just kind of arbitrarily drawing a limit at what is supposed to be the duration it takes a photon to travel across its own diameter. I think that's how Planck derived his constant. And if someone knows this better than I do, please correct me. But we don't know if a photon is really like the the smallest unit in nature, or the electron. I mean, these could be made of smaller primates, right? And so Whitehead, I think, is just saying, you know, it's at this scale, this is as accurate as we can get. And so he's trying to make sure we realize he's talking about an abstraction when he says primate, even though the reality is there probably are these enduring organisms which have a real concrete duration. But for the purposes of, you know, the mathematics, we're just going to draw a limit, you know, at an electron or at a photon, and work with that to make measurements and predictions, and it works extremely well. Yeah.
Izak, if I understand your question correctly, or the issue that you have, not issue, but what you find fascinating or potentially interesting is, if I draw on this analogy where he talks about the British and the American currencies, so that you don't really have one single constant or something that would be universal, so that you don't really have, say, a discreteness that is necessarily universal, but a discreteness that is organic and that is limited to these specific, I don't even know what to call them properly, but say wholes in a certain sense, or organisms, or the organismal environments that are constituted. So Planck constant would be universal, and what you get is a certain, what do you call them? Variations of the same constant. So you can you have several ways of multiplying this constant, but you have a constant that is there. But from what Izak is inquiring, if I understand him correctly, is whether this is something that Whitehead would basically oppose. You don't necessarily have one Planck constant as such. Is this what you're getting at, Izak? Because I also had this impression when he introduced this analogy of two currencies, which are different, and I had the impression that also even this constant aspect is kind of, but on the other hand, you can provide a specific ratio between the two currencies, can't you? So you would still have a certain ratio there of a certain smallest primate with regards to something else. So I don't know.
But afterwards, he says that at the very end, I think that the processes don't have to be, the quantum organisms don't have to be in sync with each other. So basically that you can have incommensurable organisms, if I get it. I mean, I'm not sure what really this extensive continuum, how extensive or continuous it really is. Because if one would say that it's really mathematically continuous, then you would have to have the possibility of obtaining organisms which are incommensurable with each other, right? So irrational organisms or something like that.
Irrational. Okay, I had, when I was reading this and as I was kind of jotting down some of the questions, maybe what we could do, and I don't know, maybe Izak can take the lead and then other people might chime in, Matt in particular, is maybe we could go slowly through some of these conceptions so that we get a better prehension, a better grasp of them. So, you know, when he moves through these notions, we've already touched upon these fundamental notions, but, you know, starting already from the page 100 and where is it? 11 and 20, when he wants to differentiate between time and space. So he brings in an event. So, okay, let me try to explain how someone who is acquainted with with Whitehead's philosophy, Whitehead's thought, but is not necessarily acquainted with it or closely familiar with it, might read these things and some of the questions that might might occur. For instance, when he talks about an event, right? So usually when he draws on examples, if he even bothers to do so, to say what an event is, he would revert to some sort of a phenomenological account saying, at least in this particular book, saying that this is the one that you can most easily relate to. So he would talk about an event in terms of one's body, where you have, you know, how things in the body and its perceptual field are unified in the act of prehension. And this is something that you can understand because you have, say, a certain positioning of your body as a whole, which results also in the unification of a bodily posture that then correlates to the unification of the visual field. So you have a very vivid account of this. But then he just kind of takes this out, so that the notion of event, and he just says when there are these events and these events happen, and you know they can happen, but they don't necessarily have to be effective. So they become effective only when they constitute a pattern that is somehow stable, right? Okay, this is where things are supposed to become interesting. So, and this constitution of a pattern, a stable pattern, is what, in his view, differentiates time from space, if I understood this correctly, because time is something that is enduring, whereas space, as Izak said, not so much, or something like that.
But, may I just ask something? I kind of get this distinction between space and time, but I'm not sure really that it is valid in a sense. I kind of feel what I would feel the same way, but is that really so? That that you can't speak about spatial
endurance?
Yeah.
Well,
it's a bit weird question. I just don't know how to. Just it seems that there might be something there, but if it's a stupid question, just that it's not so asymmetrical, like space and time. That he also speaks at some points that there might be different ways events differentiate between space and time, and if it is even differentiated from the very beginning, I'm not really sure how to interpret that, because he's very kind of, yeah.
Okay, just one more thing before Miha adds his thoughts on the matter. So how does then this realization of time, or realization or spatialization, or however he puts it, I forgot, which constitutes the epoch or arrest. So this is basic. Can we go into this a little bit more, you know, so that I'm clear on these fundamental notions? So I get the notion of an event and the grasping of aspects, or the prehension of aspects in the event, what it means, what it also means constituting a pattern. I think I know what it means to have a constituted stable pattern or enduring pattern of sorts, and why this is important. But then, you know, this process of realization enters the picture and other things. So maybe if we can and I don't know if this is even possible, Matt or Miha, like, can examples be provided, you know, so as to make this more organic or plastic? Funnily enough, you can use both in this particular context. Anyway, Miha.
I would actually add a remark specifically on this differentiation of space from time, or time from space. I personally also had difficulties when firstly reading these passages, right? What kind of differentiation is Whitehead really talking about, right? I actually understood it in reverse, right? I didn't understand it that at first we have a kind of differentiation but in virtue of there being such things as enduring objects, we have differentiation. Or or even in a slightly different sense, for there to be a possibility of something like enduring objects, space must be something distinct from time, and time something distinct from space. They mustn't be just one thing, right? Or in another sense, if we are talking about space, time, or if we're talking about the relation of the two, well, we must presuppose a difference there if we want to have a relation, right? And where this led me actually was the remarks, which are also very fascinating, which Samuel Alexander makes about this notion of space and time. I mean, a dead giveaway is probably the fact that his book is already entitled as Space, Time, and Deity. So what Alexander is actually doing is, at least I thought was of particular interest here, is that he's really looking for the relation between space and time, right? He's really interested in that, specifically not space by itself and time by itself, but specifically how they are related. And he states that they are not symmetrically related, right? The ratio, if you will, between time and space is asymmetrical. So for every point of space, it leads to instants of time, and for every instant of time, it leads to points of space, right? So they're kind of intermeshed between. And the things that are actually intermeshed are succession from time and continuity from space. Or in other words, time is what actually makes all the difference, if you will. It's what gives the notion of difference, in time and space is then what facilitates this difference, is, I guess, open to it, and I guess nourishes, this difference, right? So it just isn't a kind of passing moment, because if we only had succession, well, then the universe, I guess, or reality would be just perpetually recreated, right, anew in every moment. If we only had continuity, well, then there would be only this blank, right, or crystallized kind of sameness. Or in other words, as Alexander says, in order for, I think it's, in order for time to linger, space must recur, right? Or we can say in another sense that for space to linger, right, the lingering of time is there in virtue of space, and then again the recurrence, right, of space is there because of time, right? Because why would anything need to recur, right, if it's just a mere blank, right? And in that sense, I understood, I guess, this passage, right? So that the time aspect here is supplying, I guess, a kind of, well, difference, really. And then the community or the extensiveness there, right, is what is open to this difference, and I guess gives it, it doesn't allow it to be just a simple moment, right, a passing moment, right? Yeah, that helps at all.
I'm just getting more and more confused, truth be told. Yeah, I just want, maybe if I add something here, so, and maybe you can comment on what Miha is saying. And Miha, would this be related somehow, what you said? So at least partly to Whitehead's notion of reiteration, which he introduces instead of endurance, saying that he wants to be more specific. So that endurance should be understood as reiteration, precisely so as to get away from what you said, that you would have just this crystalline lump of a moment, so to speak. But time is, it is what differentiates an event that just occurs and in a certain sense dissolves, and an event that establishes a certain continuity or a possibility of reiteration. And the way I'm trying to understand it, say you have certain aspects that occur, right? Whatever they are, certain aspects, certain something. And then if these aspects get somehow grasped into a whole, whereby this whole, once it's constituted, determines the nature, orientation, and interrelation between these aspects, this is the event. And if this structuration that happens, this configuration that you get, but when this event is constituted, becomes enduring or is capable of reiterating, then this is basically, in a certain sense, the genesis of time, because it's what differentiates space from time. Space would be only when you have a certain segment or a segmental constitution of a whole, which, however, can then simply dissolve. It's just a momentary thing. But with time, I don't know if you can even talk about space then. I don't know, not sure. You know, with time, what you get is this endurance of this new structure or patterning. And this is basically, it's always spatially, it's always, so when I look at something, right, I always see certain aspects or certain segments of a certain something, but what constitutes this certain something, which is given to me in a limited way as a whole, is precisely this endurance or possibility of reiteration, which kind of it's its temporal aspect.
So I started thinking about this weird question that I posed when I was thinking about the placement of instruments in a symphonic orchestra, right? Because one can say you have a temporal pattern of a melody, whatever, a symphony. But actually this temporal pattern gets realized by the positions at which particular instruments are. If the brass were too close to the audience, they would be much too loud and they wouldn't be able to play. If the strings were much too far, it also nobody would be able to hear them. Now, maybe this notion could help. At one point, he says that, sure, one can apply Zeno's paradox to time and space if one kind of materializes them, but to the notion of movement, one cannot do that because there is a relationship between time and space. Maybe that's somehow helps, because the moment I think about how to speak about, or even you have new contemporary practices in opera and concert where people are walking around the hall, and it seems that the difference is not in the timeful aspect, but rather in the spatial pattern, right? You're listening to space, which is weird, but maybe, you know, they're not just standing there, they're moving, right? Which is not also just time or just space. It's maybe, as you said, it's a certain interrelationship between both. And it's not really that time is somehow better or more important. It's just that it supplies a specific difference.
Trying to find the best angle in here to provide an example. And I think I've been trying to work with, you know, the human body and human perception, the human organism as an enduring entity, or an organism in Whitehead's sense, and how we differentiate space from time. You know, it's very difficult not to spatialize time and in that way collapse this creative dimension of temporality that Whitehead is trying to wrestle free from the scientific materialist orientation, whether Newtonian or Einsteinian. And so I'm also kind of thinking of Bergson in this context, of course, and his distinction between perception and memory, where, you know, memory would be a felt sense of what has been reiterated. Memory has to do with the temporal dimension, obviously, whereas perception has to do with the spatial. And so any enduring organism is going to have this sense of differentiation, in the sense that there is a memory of what has occurred already, which isn't present anywhere spatially. It's sort of, where is memory? It's in the sort of internal tension of the pattern being reiterated, and the relationship among the patterns present versus the patterns past, whereas space is going to be more experienced as the potential for motion, for movement through it. And I think the place, Whitehead doesn't explicitly bring this in these chapters, but I think he's also trying to carve out some space, carve out some room for agency and aim in nature, even at the physical level, whereas in a standard Einsteinian conception, that's not even being taken into consideration. So again, Whitehead's trying to make his organic understanding of the genesis of new events that arise out of this. He calls it substantial activity in this book. Later, he'll call it creativity. How does novelty arise out of creativity from moment to moment? How do new prehensive unifications occur? Which for Whitehead is a process which we need to approach metaphysically, but somehow be made consistent with what we know physically. And so the spatiotemporal continuum and the various geometries that are used to measure that continuum for Whitehead have to be derived through what he calls his method of extensive abstraction from a more concrete process, which is the life of nature, the creative dimension of nature that cannot be measured. And so I think part of the difficulty here is that he's not always clear when he's trying to translate between these two domains. You'll recall he brings in Spinoza and makes this analogy to Spinoza. Spinoza's substance for Whitehead becomes a substantial activity, and Spinoza's modes for Whitehead become events or later actual occasions. And he wants, unlike Spinoza, to give those occasions preeminence over the one substance. The particulars in Whitehead are where all the action is, versus the more of this holism you get in Spinoza. And so, I think when Whitehead talks about an event, an enduring organism, as the reiteration of a pattern in events, and then the patience of the community for those reiterated patterns, he's trying to bring into coherence a description at the level of the part and of the whole. No pattern can be reiterated by a particular event unless there's room for it, so to speak, unless the environment is patient of it. And there's a way in which the spatiotemporal continuum is an abstract rendering of what, concretely speaking, is a discontinuous process of realization. And so how do you get the discontinuous creativity to fit within a spatiotemporal context wherein the measurements suggest there's a continuity? And I think what Whitehead is saying is this is where this notion of the patience of the environment or the patience of the community comes in. A pattern will not be able to endure through these individualizations unless the community, unless the environmental context allows for it. There has to be consistency there. But that's not to say there might not be one event that realizes a pattern that's not consistent with its spatiotemporal environment. It's just that it won't be effective, right? It'll be forgotten. It'll be diminished. It won't have any effects, right? And so, I'm trying to highlight the organic dimension of Whitehead's metaphysics, and how the part of the struggle in these chapters is for him to relate his philosophy of organism to physics, relativistic physics, and then the importance of measurement in terms of a spatiotemporal manifold of some kind. And it's not an easy translation, but at several times he says, like on page 123, he says, in an organic philosophy of nature, there's nothing to decide between the old hypothesis of the uniqueness of the time discrimination and the new hypothesis of its multiplicity. It's purely a matter for evidence drawn from observations. So in this sense, in a way, he's bowing to the Einsteinian paradigm and saying this has been empirically validated. We need to conform our metaphysics with it. But on the other hand, he's saying there are independent reasons for establishing an organic conception of nature. And that conception of nature doesn't decide for us whether the relativistic or the Newtonian approach is the real one. And so, he's just struggling to do his best to bring organism, to bring aim, to bring of becoming and creative advance into our conception of physics, where there's not an easy fit there. And I think we're witnessing his struggle to make sense of this, and so the fact that we're struggling to interpret him is no surprise. I do think it's clearer in Process and Reality, but not clear enough, that I can interpret it without confusing myself on occasion.
Okay, I have a question that is, I would say, related to what we were talking about and what you've been saying just now, Matt. So it is related to internal and external relatedness. So as Izak pointed out, Whitehead says that whatever pertains to a given event, say to a given event as a dynamic whole, so the relationships within that particular event and for that event as a whole, is internally related. The way I understand this is through the concept of a field, where you have a field as a dynamic whole, and each separate aspect of that whole is basically, in a certain sense, determined by it determines the whole, but also it is determined by the whole. So there are no separate discrete elements, segments in that particular whole, right? So these are only aspects, and they modify each other in a unified way. Okay, but he also says that the relationships between a given event and other events, as well as with the, what does he call them, primary or primate elements or whatever, is an external one, right? So if I understand this correctly, so this community of events and the relationships within between them is an external one, which means that there is some sort of an autonomy of each event. So I guess this is also why he talks about the patience of a community of events. They have to provide room for that particular event to happen. But how does this relate to the overall substantial activity? Or if I don't pretend to understand the Whitehead's understanding of God, but aren't these events also somehow embedded into this overall process that is somehow unfolding, and thereby they should also be aspects of that particular dynamic process, which means that they would have to be internally related through the perspective of that particular process. So, I understand what he's trying to say. Once you get a autonomous dynamic whole of sorts, which he calls event, you have internal relations within them. I also approximately understand why he would say that there are external relationships between these autonomous dynamic wholes. But I don't understand why these relations wouldn't actually be internal if you take them from the perspective of the substantial activity. So this dynamic version, Whitehead's dynamic version of Spinoza's substance.
I'm just typing out some thoughts, but basically I would say that in Whitehead's scheme, external relationships are always going to be abstract approximations useful for measurement, but that to consider the universe concretely, we're always going to be dealing with internal relations. And this is an important reminder that Whitehead always makes, that any perspective upon the universe is from some actual occasion of experience. There's no outside perspective upon the universe, and each occasion of experience is its own, constitutes its own epoch and exists within its own frame of reference, its own space-time system. And so it prevents us from, it forces a shift in our conception of what a scientific or physics perspective on the cosmos would be, in that it requires that we accept that our models are only ever going to be approximations, which is asking a lot of physicists who are kind of inheriting a scientific materialism, where the assumption was that the model would eventually be indistinguishable from the reality. And Whitehead's saying, no, the reality is constituted by a network of internal relationships. It's never the same twice. Nature is creatively advancing. And so I think there's a resistance among physicists because it makes the sort of relationships that they're used to measuring and modeling nature in terms of, namely external relationships, it makes that a secondary kind of derivative abstraction from a more primary, concrete experience. And it's a big ask. It's not just a new scientific paradigm. It's a new relationship to science itself. And so, yeah, that's part of it. Now, the connection to Spinoza, I think I'm not sure how to, because he's drawing analogies to Spinoza, even though his own scheme is quite different. I think Spinoza would similarly see all the modes are internally related, such that ultimately they are, as independent beings, unreal. Only the infinite substance is real, and the modes are kind of, to the extent that we distinguish them, it's a function of our confused perception, right? If someone knows Spinoza better than me, please fill in the blanks there. But in Whitehead, again, the modes as actual occasions, or as these epochal durations, these events in science in the modern world, they are not, even though they're constituted by their internal relations and the way that they unify the aspects of every other entity or event in their environment, there's still some individualizing activity which allows them to unify and establish themselves as individuals. And so there's Whitehead's is a relational ontology, but he also says that it's atomistic, and that it's precisely through this atomism that he gets out of Zeno's paradox, that he preserves some sense of individual freedom, that he makes it coherent with quantum theory and this continuity. And so, you know, this is where it differs from Spinoza. And I shared a few lines from Whitehead's Principles of Natural Knowledge about events, time and space, and how he differs from Einstein, who still has this notion of material or mass. We could say, on the old theory of relativity, time and space are relations between materials or masses. On our theory, they are relations between events. And so that's the difference between internal and external relations, right? Materials would always be externally related, whereas events are not.
Yeah, so if I understand you correctly, so from what you're saying, it's more or less, in a certain sense, one would say that in let's say, the most philosophically fundamental way of viewing at things, you would talk about what he's now referring to as external relations as internal, if taken from this, say, ultimate processual perspective, from the perspective of the dynamically unfolding God or what have you. But when you're talking about them, say, from the perspective of a physicist who is doing, who is investigating space and time and the elements within those, within space and time, it makes sense to draw this differentiation where you introduce the notion of an event that is characterized by having the internal relations, and then the community of events where the relations are external in a certain sense. But this would be, if I understand you correctly, a provisional distinction. So it wouldn't be an ultimate distinction in the sense of that from this deity perspective, there are but internal relations in a certain sense.
Mm-hmm.
Yeah.
Yeah, I think that's a fair way of putting it. There's also, you know, Whitehead was a member of the Aristotelian Society, this group of philosophers. I think he started going to their meetings in 1915 or 16, and relativity theory was one of the main things that they seemed to be discussing at most of their meetings. And a lot of the other philosophers there were idealists and had an idealist interpretation of relativity. When, you know, Whitehead says that he's looking for, in an earlier chapter, a provisional realism. Here he says in the relativity chapter, he wants an objective rendering of what's going on. And so, you know, this is why he's not satisfied with just an account in terms of the genesis of actual occasions. He also realizes that a morphological account of the spatio-temporal continuum as a real condition that actual occasions in their genesis must conform to on some level. You know, that's his provisional realism. That's his attempt to make, at least, to render this in an objective way. And, you know, in order for external relationships to be, in order for physics to be done, you need external relationships. Otherwise, you can't distinguish one thing from another. You can't distinguish, you can't provide measurement. And so, yeah, he's really trying to accommodate his organic ontology to a metrical understanding of space-time. But what that implies for Whitehead, at least, is again that this metrical conception of space-time is secondary to and derivative from the activity of actual occasions. So actual occasions aren't in a pre-given space-time. each occasion is providing its own space-time, and then through this metaphor of the patience of the community of events, these various space-time systems are brought into relationship with one another. But yeah, a metaphor I've used is to think like the difference between Einstein's view of this and Whitehead's is that Einstein will often talk about the fabric of space-time, and it's a continuum. There's no fraying in it. There are black holes, which are singularities and kind of strange. We'll just bracket those. Whereas Einstein sees the space-time continuum as an unbroken fabric, again, bracketing black holes. Whitehead sees the space-time continuum as a frayed fabric that's constantly reweaving itself through these epical realizations, so that it's more it's more dynamic, I think, and it brings home the creative contribution that each event or occasion of experience brings to the further unfolding of the space-time continuum. It's not like a geometrical manifold that's just sort of there as the context within which events occur. It's in some way, derivative of the activity of these events.
Matt, one thing that one reason why, for instance, someone who is not necessarily particularly fond of this type of thinking, so say a more classically minded naturalist might have issues with what Whitehead is doing, he, at least not in this particular book, he never really provides criteria for what it is that constitutes prehension or grasping. So, what is it that delineates an event? It is always something that you can talk about post hoc. So when it happens, you talk about it. But he doesn't really provide criteria. So what gets encapsulated in a given event? So why, for instance, you have a certain entanglement between two parts that are taken separated and they're put on the opposite sides of the universe and they are still entangled, but two identical twins, when one of them goes and flies around, there's no entanglement. So, how does one account for these intermeshments or entanglements within an event? How does one draw a line of an event, so to speak?
I think empirically, so there, in that sense, it's a matter of convention. Quantum particles that are entangled constitute a single event in some sense, whereas the two twins are enduring organisms, each in their own right. And, the twin paradox, so much has been written about it. It seems that at smaller time scales, we've been able to verify that, yes, this effect is real. When you factor in acceleration, I think it helps to, I don't know if it helps, but my understanding is that the original formulation of the twin paradox didn't factor in the effect of acceleration on the aging of the moving twin. Initially it was just special relativity, and so there was a relativity of motion in the sense that you just as easily could have understood the twin on Earth to be moving as the one in the rocket. When you add gravitational effects and acceleration, it changes things. Bergson didn't think that it was a real effect, and he seems to have been wrong about that. Whitehead doesn't really weigh in one way or the other. It's really quite confounding. I can't unfortunately clarify it for you, but I think in terms of Whitehead's understanding of what constitutes an event, what constitutes an actual occasion, he doesn't mean just a very small quantum, duration. It could be of any size. Any duration, that is, any length of time. However, these are, an event is non-local in the sense that, he'll say any local agitation shakes the whole universe. So there is no finite size to an event. It's just a matter of the unification which takes place, the prehensive unification which takes place gives rise to a center of experience. And that center of experience is located at a perspective, but it's a perspective upon the whole, even if, in the case of each moment of our human experience, we're not conscious of the whole. We're conscious of a very thin slice of what's actually going on. Nonetheless, all of what's going on is ingredient in what's unified into our perspective. Some of it's negatively prehended, some of it's below the threshold of consciousness, but nonetheless, it's contributing to what does manifest in our conscious perception, right?
Yeah, just a small, very, very small comment on this. The thing is, the main problem, again, from the perspective of someone who is acquainted with Whitehead, but is not necessarily very well versed in his philosophy, is if you have, let's say, the notion of prehension or grasping and unification related to something like living beings or mental beings, there is a certain way or a certain criterion whereby you can say, well, this is what we normally see as unified wholes that behave in autonomous manners. But then if you take this out and say that basically there are events of similar kind happening also at the scales of where you don't really see them, and on the scales of entities that some would claim are basically abstract postulates or conceptual constructions, such as, for instance, subatomic particles or, say, strings or what have you, you have a problem there. Because, saying that you have a unified organism that is constituted as an autonomous dynamic whole, you basically need a separate argument and a separate criterion for that. Already at the level of organisms, living beings as such, you have a problem, but I think that you can make a very, very strong case for this. But then taking this out of the context, without providing necessarily a criteria where you can find these unified wholes, you can, the problem is that you can get a really, really bad case of proliferation, almost a conceptual diarrhea, where, what you take as prehensive wholes are basically certain entities that are endorsed at a certain time by the scientific community. So maybe after 100 years, nobody will talk about atoms anymore. Will they still constitute? Will they still count as organisms, or will they fall by wayside? So this is the problem, because you're kind of following the footsteps of science. Science uses atoms at a certain point of its description, at a certain period of time in its way of accounting for the world. But when this happens, you will change the notion of organism. And if this is the case, your notion of organism doesn't really do its work, because it didn't really tell you that this is not an organism.
Well, this is the importance of the demarcation between science and philosophy. I don't think Whitehead was trying to collapse philosophy into science, which is why he refers to primate organisms instead of electrons, say, because he knows that science will continue, and the scientific object may change nature as we learn more. But Whitehead's hope is that his metaphysical scheme will still be applicable to whatever science uncovers. And so he's trying to make his metaphysical scheme generic enough that it applies to the current state of science, offers an adequate account, again, in metaphysical terms of what's going on in terms of this philosophy of organism, but that I think he's trying to avoid equating. This is why he doesn't equate primate organism to a specific particle in the standard model. The standard model itself might get thrown out. And so, yeah, I think he's still respecting the difference between science and philosophy, which is why there's some vagueness here in his account of what constitutes an event, what constitutes an enduring organism. His claim, though, is just that nature is a community of enduring organisms, and that each organism is an epical realization that unifies aspects of its environment and contributes a novel perspective. That claim, I think, is durable against shifts in our scientific understanding to a certain degree. So science can continue to advance, and it has in the last century, in a way that I think only further, confirms the generic account that Whitehead was attempting to give, which doesn't mean that will continue. And I don't think he thought that his system was a finished, eternally true account either. So it's sort of a method. It's the best we could do now to interpret the scientific evidence, is what he was aiming for.
Very nice. Adnan and then Izak. Now shut up.
I think you sort of already started to answer my question. Basically, what I wanted to ask about is if the delineation of events, so the line between them, is purely a matter of convention, doesn't that have basically the same effect as saying that there are no external relations? Doesn't it have the same sort of Spinozist effect of making measurement, in a sense, impossible, or rather just purely a matter of convention, which, if I understood you correctly, is something that Whitehead was sort of trying to avoid precisely by not following the Spinozist path?
Yeah. Well, Whitehead does want to say that that events, and again, I'm sorry I keep leaping ahead to his language in Process and Reality, but it just is clear. An actual occasion arises and perishes. So there's an arrest. It's not indefinite in its duration. There's an actual moment of perishing where its nature changes. Its nature, so if we speak in terms of subjects and objects, right? An actual occasion that is in the process of genesis, where it is unifying aspects of its environment, bringing them into contrast so as to synthesize them into an individualized perspective. That process is a duration, but it's a subjective experience. But once it's realized, once that perspective is synthesized, that subjectivity perishes into an object. And so while in its process of subjective formation or genesis, there's an internal relationship between that entity and everything else. Once it realizes its perspective perishes into an object, then external relationships take hold. Because the entity, the actual occasion or the event has realized itself, and then it contributes itself back to the community. And if the community is patient of it, it will be reiterated and it will endure. If the community is not patient of it, it will be ineffective and dissipate. And so there's room for external relations in the perishing of an occasion of experience into he calls it a superject or an object. Yeah, does that help differentiate it from what Spinoza is saying?
Yeah, that was really sort of a conceptual link that I've been missing. It makes it much clearer. I mean, I don't recall finding it at least that explicitly in this book. So, yeah.
No,
thank you.
This is process philosophy in process in science in the modern world.
May I? Yeah. So I actually harken back to the relationship between internal and external that you. So I read it in. Sebastjan will know I'm really enamored with Rheinberger and Cartwright, and basically Nancy Cartwright's point is that science never really develops any fundamental universalist laws. It might appear after the fact, or there might be a cosmological interpretation of it, but basically the laws that function are tied to the experimental systems that we can interpret with them. So if I say there's an atom, or I just read an essay about her interpretation of quantum mechanics. Basically, she says that there's not a real quantum mechanics, like metaphysically. There's a specific interpretation of classical properties that one can implement quantum mechanically. So basically, I find this very similar to Whitehead with my interpretation, because in this respect, and here's where Rheinberger comes in. He says that you can differentiate in science between so experimental epistemic things and technical things, right? And epistemic things are gonna be, one can say, creative. They're gonna unravel from the inside. They're gonna show new dynamics that were not obvious from before. So they were kind of internally motivated. While on the other hand, so the technical object is going to be purely like a black box, so like Latour would have it, right? And here I see a connection with Cartwright and Whitehead, because they both say that it's really important to delimit the internal and external factors when you look at an event. That, of course, is missing in Rheinberger. And Cartwright would say, for example, interpreting electrodynamics, that if you really want to have an experimental system within which the electromagnetic laws hold, you have to bound it so as to not lend it to gravitational influence too much. So basically, you have to bound it from the external relationships that it has with its environment. You have to introduce a certain artificial patience of the environment for a specific experimental system in order to be able to predict it. Of course, she doesn't really provide a framework for how this boundness occurs. It's kind of like in Flick, like it's just some genius comes and does that. So this could be very also creative. But the point is that, yeah, once the experimental system, which is bounded with a creative intention, gets so sedimented that that nobody really pays attention to the internal aspects, then it becomes just a factor in relation to the external aspects. And by that interpretation, one could say that everything that Whitehead says about science is just provisorisch. It's on that basic juxtaposition of external and internal that contemporary scientist is. Nothing is in that sense final. I found it really nice, this kind of metaphysics without scientism, or in a way that I mean, even in Husserl, you have kind of a mathematics of metaphysics. But here I really found, for example, the way I understood this organic constant was actually that, like you said, Sebastjan, I think, so until now we were able to use this constant, but it might change. And also, I think he would perhaps say about any constant or any system, like the events we're investigating now can be very well understood through these dynamics, but at the moment, at a certain point, there are going to be external dynamics which will influences the constructed system to such an extent that it will be unable, we will be incapable of supporting its universal applicability. Does that make sense?
It does. Let me intervene just a little bit while Matt collects his thoughts, which he's doing, it would seem. By the way, Matt, just to let you in on this inside thing that you saw happening there are just certain notions or terms that keep recurring over and over again. They are very enduring in our meetings, but in a way where they are repetitive, not in a substantial. No. and sedimentation is one of them. Gestalt is another one. So whenever somebody says that, you're probably going to see a few chuckles because of that. And one thing that I would add to what Izak was saying is the following. If I understand Whitehead correctly, his idea about, say, the changing nature of certain constants is not so often. The general idea is that if a certain constant gets abandoned, or if it changes, it is because physicists were able to get a better view of the reality. So the older constant was either a very like a more rough approximation, or it was wrong for one reason or another. But with Whitehead, it would be the case that even so, the constants would modify themselves in time, because the reality as such is processual, and thereby, if a constant changes, it is not necessarily because our instruments have improved or our methods of doing science is improved, but because the universe itself is changing in a certain sense. And this is something that I wanted to touch upon last time, but we ran out of time. So there's this notion on page 7 where he talks about the evolution of laws of nature. The evolution of laws of nature. And I was reminded here by this enfant terrible of contemporary science, namely Sheldrake, with whom you had a nice interview, who basically says that laws of nature should be called habits of nature, and that these habits change. And then he provides a really interesting, well, he provides several examples, but one I found extremely interesting, namely the example of the boiling temperatures. And he says that when he was checking out the data for the boiling temperatures of certain substances, they changed through time. And the thing is that whenever he would talk about chemists about this, he said, well, why does the boiling point become lower after some time? And he says, well, that's just because we have a purer substance. And then he asks, but how do you know that you have a purer substance? Well, the boiling point went down. So you have a strange circular reasoning. And the point that he's trying to make is, so the way he presents it is that if there's a certain substance that's been around for long, it becomes incorporated into the whole in a way where it becomes stabilized. And after a while, the constants don't change as much. But if you have new substances, the constants change. And the funny thing is that they change even if you measure them in different laboratories. And there was this, like, one way of accounting for this was some professor's famous beard. There was like this chemist who would carry the crystals of these different substances in his beard. So whenever he would come somewhere and he would measure a certain melting point or whatnot, it would be pretty much the same, because he actually brought these crystals, and that's why they became unified or coherent in different places. But anyway, that's just one example. And Whitehead seems to be putting forward a similar understanding of laws of nature. So laws of nature that evolve, that change. And so when you get different constants, you don't get different constants strictly for the reasons that Izak mentioned, but also because the structure of the universe or the dynamics of the universe itself changes. That's another layer to the whole problem.
Yeah, I think my understanding of this has been improved recently by reading a book by a plasma physicist named Timothy Eastman, who's influenced by Whitehead, but also Charles Saunders Peirce. And Peirce is another figure who conceived of some of the laws of nature as more like habits. But what Tim Eastman points out is that, well, there's a difference between physical and mathematical constants. Physical constants are measured. Mathematical constants have a different kind of necessity. And so what I think what Whitehead would say is that yes, the physical constants, the things that are measured, are subject to evolution over the course of cosmic time. And, you know, one way of making sense of the so-called fine-tuning of the fundamental constants is that in the very early moments of the universe, these so-called constants were co-evolving with one another, constraining one another, such that what looks like miraculous fine-tuning to us today is just an artifact of not thinking in a genetic way about how the various enduring patterns of nature originated. They appear fine-tuned because they were in resonance with each other from the beginning. And we measure them all now, and it seems like, wow, there's these 22 or whatever, you know, different physical constants. And it's like, they had to be however many decimal places, you know, exactly what they are in order for even an atom to form, much less a star, or for the chemistry of life to be possible. And it seems rather mind-blowing and leads to either fuel for creationists or to a multiverse theory where chance is brought in to explain how, well, there are infinitely many other universes where the constants randomly arrayed themselves differently and nothing of any significance emerged in those universes. And we just happen to be in the one where, you know, the constants were just so that here we are to reflect on the fact. Whitehead is saying, if we conceive of an evolutionary universe, these constants were brought into tune with one another through a process of resonance. I mean, this is what he means by the patience of the environment. As the universe expanded, what we call the constants differentiated and took on their form, always internally related to one another, right? Does this make sense? And so, but on the other hand, there are mathematical constants which have to do with the way that, you know, in Whitehead's scheme, he thinks that there are certain mathematical relations that have to do with establishing congruence that are truly eternal. They're truly metaphysical in the sense that every cosmos, every cosmic epoch must include these features, or it can't even develop into anything. And so there is something in Whitehead that's still eternal. I mean, this is where the primordial nature of God comes in to establish these sort of mathematical conditions, if you want, that allow for organization to arise. But when all the physical laws that are a function of measured constants, gravitation, speed of light, whatever, these, Whitehead would agree, change. They're more like habits than they're habits. They're not eternal. So there's a bit of nuance there as to what exactly is a habit and what is truly a law. Tim Eastman makes this point as well, that there's something about the structure of the quantum vacuum that does not seem contingent, that it seems like there's a mathematical necessity there. And at this point, it's a bit beyond my pay grade, to really, I'm just relaying information from what, I've learned from the physicists at this point.
It sounds like, just, I don't know how basically you could substantiate the claim that he's making, because this has been going on for decades now, saying that, well, there are these contingent laws, but there are these fundamental laws. And then you have Newton's 3 laws, and they were the real deal. And then they turned out not to be the real deal. And the same for the theory of relativity, the same for quantum mechanics. It just seems like you have to postulate this. You have to posit it. So you have to posit that there are these mathematical laws and that there is a certain difference. But I don't see any way of how you would actually go about proving it. I mean, he can say that there is something, that it seems to be the case, that there is something about the properties of this particular quantum field that seems to be universal in a certain way. But then again, you know, this was said for so many different things. And at this particular point, I think that what Izak was saying, you know, this point about physical laws being encapsulations of a specific ordering within specific limits is a very valid point to make. And at least from a historical perspective, I would say that the other side is called upon to provide arguments as to why this is not the case. If in the past, the situation was reversed, after having gone through so many modifications and transformations of very profound nature, so these weren't just, you know, cosmetic additions or embellishments, but actually qualitative transformations of the laws themselves and the implications they have for the nature of reality. You know, it just begs the question to say something, what you've just presented, that there are mathematical laws that seem to be universal. It's a very strong statement, and I understand that it may seem like a very convincing statement in a specific time frame. But whenever I hear something like that, I cannot but wonder what will happen 200 years later, or even 50 years later on, you know? So this question about epistemic humility regards to that. Any other comments, maybe, so that we don't tire Matt out completely? Unless, Matt, you would like to keep on going.
I mean, I wanted to ask this last time, but actually I can't imagine how these mathematical laws would look like. Because I presume they could be different from how a scientist would formulate them. That perhaps there is something, even in this constant approximation way of constructing scientific experiments, but basically because mathematics is useful, we can say, okay, there is something mathematical in the background, but perhaps these laws, I don't know, perhaps these laws are not the laws like of gravity or of the relative transformations of space and time and stuff like that. Perhaps the way I understood the last time we were talking about eternal objects, there was something in the structure of mathematics, mathematical objects, that gives rise to these laws. Perhaps I misunderstood, but I can't really imagine. Perhaps that's a completely different way of understanding a scientific law. I'm not sure.
I think we're at the end of our time, but are any of you familiar with Peirce, the American pragmatist? Sebastjan, a little bit. Well, I mean, I don't know how helpful it is to get into his understanding of law, but you know, already before Einstein, there was a recognition that law was statistical, and that each particular entity may not obey the law. It's a matter of the statistical regularity. And so, you know, even before the 20th century revolutions in physics, Peirce was already already making the case that the so-called laws of nature, because they have a statistical nature, are, you know, there's a difference between a particular entity subject to the law and the law itself. A law is more of an abstraction. And so Peirce didn't want to lose the concrete particular similarly to Whitehead. And at that level of the concrete particular, there's always these contingencies, there's spontaneity, or there's a level of stochastic behavior. And even if in large, what's the metaphor Whitehead uses? Not herds, but flocks, or you never find one electron, you always find a whole herd of electrons, and that at large numbers, statistically, they obey a law, but any particular electron is going to be doing, who knows what. And over stretches of evolutionary time, those individual or particular electrons, say, that are veering from the statistical law, or that veering, if it again is effective over time, it's going to change the law that applies to the behavior of large numbers of electrons. And it could be that takes 100 billion years. I mean, indeed, it seems that many of the physical laws in our universe that deal with particle physics are pretty stable, but in timeframes relative to what we're capable of imagining. And so if we're going to do metaphysics, we have to keep these timeframes in mind and not reduce the universe to what it happens to look like during the historical periods that we're paying attention. So, maybe we can go more into this. I think I'm presenting next time, right? No, science and philosophy. So that we're doing just one chapter next time?
Yeah, and
Okay.
Unfortunately, nobody volunteered, so I think that Timothy will be presenting this one, because he was a substitute for basically an empty space for an X.
Okay.
So unless Timothy...
I'm gonna write one last desperate email and then we'll see.
Yeah. But Timothy, if it's any consolation to you, this is probably the best deal one gets with this book, because it's only one chapter.
Yeah, I got
it's only
it.
one chapter,
Yeah.
so it's 15 pages. I mean, those are not particularly easy pages, but then we have 2 weeks off after that. So after the next session, which is in 2 weeks, we have 2 weeks off instead of one. And then Matt will be presenting two of the most difficult chapters on abstraction and on God. And even though they make up for around 30 pages, it's a similar experience to reading 30 pages of Phenomenology of Perception. So it shows how relative time and space really are when it comes to these kinds of events. So Matt, I've kind of reserved you for that, for those 2 chapters, because they are way most difficult in the book.
Yeah. Hopefully we all survive.
Yeah, we will, for sure. So yeah, Timothy, maybe you can send out the last desperate call, and then if it doesn't work, it's just 15 pages, and the chapter is manageable. It's on the more difficult side, but it's doable.
I'm just, in case anyone wants to follow up on Peirce and his conception of law, which is quite similar to Whitehead's. Stanford Encyclopedia of Philosophy has a good section that goes into this. Maybe we can follow up on that next time.
There's also a really good, I think it was a series of lectures on Peirce. I forgot who the professor was, but I remember on one of my longer commutes that I was listening to it. It's around 5 or 6 hours. If I find it, I'll send it over the email.
Please do.
Yeah, so anyway, maybe we can wrap this up at this point. Yeah. So thanks for joining, everyone. I'll be seeing you in 2 weeks. I might be absent in 2 weeks because I have 2 conferences in that particular week. And I have 3 presentations to deliver, so it will be a very busy week indeed for me. Anyway, Matt, huge thanks for all the commentarial work that you do here. It's extremely useful.
Hope so. Yeah, it's great to try to digest Whitehead with all of you. I appreciate your efforts. So yeah, it's really enriching for me to be here as well.
Yeah, I mean, if nothing else, you get questions from very different perspectives coming at Whitehead, which is probably useful.
It's very useful. You know, I'm never done reading Whitehead, and there's always more to understand. And there's always occasions where I realize that I thought I understood, but I didn't, you know, and that's a process of, I guess, widening circles of comprehension. But it's clear that even in Process and Reality, I've been trying to show how there's this process of composition and Whitehead figuring out his scheme. And it's clearer in Process and Reality, but there's still problems there. Where there's some inconsistencies and things that he wasn't clear on. And so, you know, it's not just that his philosophy is describing a reality in process, the philosophy itself is very much in process. And so it's an invitation to us to critique it, to build on it, to mix and match with other philosophers, you know, to keep up to date with contemporary physics and how that changes things. So there's a lot of balls to juggle here.
Yeah, and also keep up with contemporary developments in biology, neuroscience, and so on and so forth, which are shedding very different lights on certain aspects. So yeah, anyway, thanks everyone. We will be seeing each other in 2 weeks.
Take care.
Bye. Take care. Bye-bye.